the following circuit here, we have to find IT and IRT. So pretty much these two values. So let's draw the circuit when t was less than 0. Hold on, let me change colors. There you go. When t was less than 0. So obviously the switch here was opened. And we actually have two different circuits here. Okay, so we have this circuit. And then we have this circuit. Oh yeah, then we have our unit step function. It pretty much, this means that when t is less than 0, this is 1, and when t is greater than 0, it's 0. So right now the unit step function is 1, so that means there is a voltage source over there. So this is 30, this is 28 millifarads, then there's a voltage here, and then there is 20 ohms and current of IR here, and then there's a current of I traveling here. Now we're assuming that these two circuits look like this for a long time. That means this portion becomes an open wire, and this portion short circuits. So we know this is 4 amps, and that means I, when t was less than 0, is 4 amps. And for this whole region, we know IR is going to be equal to 30 all over 40. Okay, so 20 plus 20, that's 40. That's 3 over 4. And we can find V, which will be the voltage at this region. So voltage will be 30 minus 20 times 3 over 4. And that should give you 15 volts. And this is your I/O when this is your current when t is equal to 4, and this is your voltage when t is equal to, sorry, this is your current when t is equal to 0, and this is your voltage when t is also equal to 0. Okay, because recall, current passing through an inductor can change instantaneously, and voltage at a capacitor can change instantaneously. Now let's view the circuit when t is greater than or equal to 0. So the unit step function is 0 in this case, so that means this portion is gone, and we can just replace it with a closed wire. So now we have the following circuit. So 20 ohms, 0.00 farads, 0.008 farads. This is 20 ohms. This is 20 henries. There's I passing through here, and there's IR passing through here. And yeah, and then there's a voltage here. Now the voltage of this capacitor is going to be the same voltage for this entire node region here. Okay, so we'll just dot this to be V. Now, what we're going to do is, so pretty much to get I, this is going to be broken up into two portions due to this current source. So there's going to be a transient current source and a steady state current source. Sorry, transient current equation and steady state current equation. So we're going to first find this one. To solve for this, we have to view this circuit without any sources. So that means this current source we're going to ignore and leave behind with an open wire. Now we're just going to focus on this main circuit here. So this is what we're going to do. So we're going to also have this one be I1 and this one be I2. Okay? So we're going to write the nodal equations for all of this. So this one, we're just going to leave it to be I. This one, we're going to leave it to be V over 20. This one, it's going to be C dV over dt. and this one it's going to be V over 20 as well. Okay, now we have to get rid of all our V values because recall we're trying to find the voltage, the current passing through here and through our inductor. So if we were to just solve this in terms of V, then we would get the voltage at our capacitor, and I want the current passing through my inductor. That's also why I didn't plug in the formula for current passing through inductor, which was 1 over L times the integral of V dt. So what I'm going to do is, I know the following is true. I know voltage at this inductor is going to be equal to the inductance value times the change in current over the change in time. And the voltage of this inductor is going to be the same voltage here. So I'm going to just plug in this V value into here. So it'll be I. I'm going to add these two up. So that should be V over 10. And I'm just going to plug in L di over dt plus C, the derivative of this, which will be L d squared I over dt squared. Now I'm going to divide both sides, everything by LC. So it'll be d squared I over dt squared plus 1 over 10 C di over dt plus I. And I'm going to let di over dt equal S. So we'll have S squared plus 1 over 10 C S plus 1 over, oh wait, I forgot to include one more thing. This I also should be divided by LC. There you go. That's more better. Okay. So now we need to find alpha and omega. So alpha is literally just going to be this value times 1 over 2. So it'll just be the following. And this one for omega is just going to be this value squared. There you go. So let's quickly find alpha and omega. So it's going to be 1 over 2 times 10 times 0.008. And that should give me 6.25 radians per second. And this one is going to be the square root of the inductance, which is 20 times 0.008. And that should give me 2.5 radians per second. Alpha is greater than omega, which means it's overdamping. So I'm going to use the following formula to find the current passing through the inductor, which will be A1 times E S1T plus A2 E S2T. S being my root values for this. Okay? So obviously you can use a quadratic formula, which should send you to this. So we just plug in these our values for alpha and omega to get our roots. So S1 and S2 will be equal to 0.5217 and minus 11.978. So, oh wait, and this is I transient T. So that's pretty much this part. Then we have to find steady state I. Okay, so this will just be A1 times E to the power of minus 0.5217 T plus A2 E times minus 11.978 T. Okay, now we just have to add the steady state current to this, and that will give us our IT value, and then we will solve for A1 and A2. So to find ISS, or I steady state, we pretty much take this circuit, including our source, and find the current passing through this inductor when t goes to infinity. Oh yeah, and this is a current source, not a voltage source. So this was 4 amps. Okay, so when t goes to infinity, this becomes an open wire, and this short circuits. So this whole region of the circuit is pretty much useless because all the current will just be traveling through this wire. So the current traveling through here will be 4 amps. So, and that's going to be your ISST value, which is equal to your I infinity value, which is equal to 4 amps. Okay, so recall this is the current traveling through here is I. So ISST is 4. So we'll just add 4 here, and that will give you your IT. So recall that when t was equal to 0, I was equal to 4. So we'll just plug that into here. Obviously this turns into 1 plus A2 plus 4. And now this and this just cancels each other out. So that means A1 will be equal to minus A2. Now to find, so we have one equation and two unknowns. So what we're going to do is differentiate differentiate IT, and that gives me the following. And obviously this 4 is a constant, so it goes away. So now we have to find di over dt. Okay? Alright. So we actually could just use this equation here. So v over L equals di 0 over dt. So the pretty much when the circuit looks something like this, the oh yeah, and obviously this is assuming that there's this current source here. So pretty much when the circuit look like this with our current source, we need to find the voltage here, and we actually do know the voltage here, because recall the voltage at the capacitor, it can't change instantaneously. So the voltage at the capacitor was 15, and that's the voltage here, and that's also going to be the voltage here. So it's going to be 15 all over the inductance, which is 20. Okay, so this will be 15 over 20 when t is equal to 0. This is minus 0.5217 A1 minus 11.978 A2. Okay, now you just plug in minus A2 here. The minuses cancel each other out. Okay, and let me see what that gives me. So 0.5217 minus 11.978. So 15 divided by 20 divided by all of that. You get A2 to be minus 0.06546, and that means A1 is the positive of that. There we go. And so your formula for I of t will be 0.06546 e to the power of minus 0.5217t minus 0.06546 times e to the power of minus 11.978. This is in amps, and this is the current passing through this inductor. Now we need to find IR passing through this resistor. So IR is going to be V over the resistance, which is 20. And we know that V is also equal to the inductance times di over dt. So it will be L times di over dt. Okay? So IR of t is going to be equal to V over 20. And V is going to be 15. Wait, sorry, not 15, my bad. Sorry. V is equal to L times di over dt. Yeah, okay, sorry, yeah. So V is equal to di over dt. Sorry, L times di over dt. L was 20. Okay, so 20 over 20. This is all gone. So it's just di over dt. So just the derivative of all of this. So that should give you minus 0.03417 e to the power of minus 0.5217 t plus 0.7846 e to the power of minus 11.978 amps. Okay, and there you go.